Hi everyone. Thanks for watching our video. I'm Pranav Kumar and this is my friend Josh Durham. Together we created the COVID-19 resource dashboard using Redis modules as our backend to do so. So we were inspired by, of course, the COVID-19 pandemic that has affected everyone throughout the world. In particular, we were monitoring the situation in India where resources were scarce, cases were overflowing, hospitals were at capacity, and we felt that there was quite a bit of inefficiency with regards to how resources were distributed. So some areas were doing fine because they had plenty of masks, they had oxygen, etc. While some other areas, they had none of those. And the areas with a lot of supplies, sometimes those supplies went to waste. And we felt that we could bridge the gap here by helping out people who need supplies and connecting them with people who had extra supplies to give. Um, and because of that, we decided to create the solution, our COVID-19 resource dashboard, which is a crowdsourced live updating app, which leverages the power of geospatial querying from RedisSearch and asynchronous batch jobs from RedisGears to live update data and ensure that people on both sides of this resource spectrum can be connected. So we have the app up here, and Josh will give a short walkthrough on how it works.
Yeah, so I guess first I'm going to go through and show how to get everything up and running, and then we'll go through some of the different features we have here. So, the main architecture of the application is on the Redis side. We have a Redis Docker container containing the Redis modules, primarily for RedisSearch and for the RedisGears, as well as publisher subscriber queues. So first, to get this up and running, you're going to just want to spin up the standard Redis Docker container. And then you're going to want to spin up, this is a Flask server, where this is going to serve as our backend that's going to make queries into the Redis databases to get the data we need, and also to set up different Gears jobs for our live streaming connections, which we send over WebSockets to our front end. So we're going to spin up this backend Flask server here. And then finally, you're going to want to spin up the front end server, which is, this is just a standard React dashboard server. And then this is just, you can spin this up via npm start. We have more details in in our GitHub repo. So we've got this up and running. So we've gotten this dashboard, a Google Maps component, which is basically going to use your browser's location information to figure out your current latitude and longitude. And it's going to set this as your current pinned location on the map. And this dashboard here is going to live update with the different locations that people are placing for resources on the map. So for people that both have an excess of, say they have extra masks, and people that also have a scarcity of masks, they're able to specify their location and their demands on the map here. And you can submit your own requests through the small form on the side. So let's say I need some resources. I really need vaccines at my current location, and say I need 5 vaccines. And I can say I want to add some resources. And this is going to send a request to our Flask server on the back end. Basically, as a post request, it's going to say, okay, I need some resources. And that'll send a query into the Redis database to basically pin at the specific location what needs you have. And then if we look back end on the server side, this is going to, just send a post request. And then we have a WebSocket here as well, which is doing this live update of the map. So Pranav can talk more about the kind of the WebSocket setup and how we have RedisGears to kind of have this all connected and working together.
Yeah, so as soon as you enter a request or say I have excess supply of resources, once the query gets sent to the Flask server, essentially it performs an HSET on the Redis side and inserts it as a RedisSearch document. And by leveraging the power of RedisSearch, essentially we create these as geo data. We add all of this as a bunch of geo data and key it by latitude, longitude. And what we do is we use the default radius that we specify when the app loads up, and we query only for relevant information within that radius. And this is where RedisSearch really pulls through and lets us do this in a really simple manner, because calculating radiuses or distances is hard and trying to filter by the data that's relevant, but it's one simple ft.search command with RedisSearch. Once that happens, we also have a couple of RedisGears job running in the background, which monitors this database for any state changes. As soon as something happens, RedisGears detects this because it's operating in key reader mode. And what it does is it publishes a message on a Redis Pub sub channel. And finally, we have a WebSocket set up, which reads from this Pub sub channel and sends it back to the front end, which can then update the map.
So an additional feature we've added to this front end here is we've added these filter for resources options, where we're able to filter for just the pins where there's an excess of resources. So if I click on the vaccines pin here, this will do another query to find all the locations via a geospatial search that are basically around my current location within a radius of 100 kilometers where vaccines are available. So it'll make great use of Redis's geospatial search options to do this query efficiently. That I can do similarly for oxygen or other resources like masks where we have an excess. And then these remaining pins that don't show up when any filter is selected are where there's a deficit of resources and they're in need of resources from one of these other locations.
So we also used RedisGears to allow us to perform matches in the backend. So this will, if there's person A with excess masks and let's say person A has an excess of 50 masks, person B needs 40 masks. Essentially, we have a RedisGears job spun up that will try to match people in as close as possible who need supplies that other people have, and such that the quantities match up as well. So this is again utilizing the geospatial power of RedisSearch, and we do it iteratively to find the minimum distance location. RedisGears does this asynchronously on every item that's added to the database, and this is streamed back along another channel and along another WebSocket. So we then display this matching data real time in a chart like so, which can tell us like how many masks have we successfully matched, or how many vaccine resources have we successfully matched. This data that we see here is currently an example, of course, because we don't have live users to test it on, but we have the framework set up and working for adding a request and then getting that match sent back to the front end. Yeah, so in closing, we think this project really highlights the simplicity and power of Redis. The actual lines of code we had to do to implement this, scale up, launch this database, which would support real-time updates, streaming results, all of that was really short. I think Redis does a great job of abstracting away all of these details while providing a high performance and flexible solution. So yeah, we hope you like this project, and we had a really great time implementing it.